So hello everyone, in this video we'll be solving another LeetCode problem and the problem name is coin change. So let us read the problem statement. So you are given an integer array coins representing coins of different denomination and an integer amount representing the total amount of money. Now we need to return the fewest number of coins that we need to make up that particular amount. And if that amount of money cannot be made up by any of the combination of coins, we need to return -1. And you can assume to have infinite amount or infinite number of each kind of coin. So what the question is saying is, let's say we are given a coins array which is 1, 2, 5, and we are also given an amount value in this case is 11. So we are taking the first example. So what the question is saying that we need to have the minimum amount or the minimum number of coins in order to make this particular amount, and we can take each amount of coin any number of time. We have infinite supply. So this is what the question is saying. So in this first example the output is 3 and the combination they choose is 5 plus 1, which add up to 11, which is equal to that amount, and the total amount of coin or the total number of coins we use is 3, 2 of 5 and 1 of 1. And why we have chosen 2 5s? Here it is only 1 because they have said that we can have infinite supply for any of the coin. So this is what the problem is asking us to find out. So how we can do that? It is, if you have solved 0-1 knapsack kind of problem, so you can relate this problem to that only. So what we can do, we have for each and every coin, so let me just write down this first, amount equal to 11. So for each and every position we have two choices, 0, 1. Either we can take that particular coin or we cannot take that particular coin. Now here in this case we have the infinite option to take this coin. So even if we take this coin, we will not simply move forward. We will again have the option to take this coin again. So this is the different thing in this question. We can have this supply infinite number of times. So simply what we can do, for each and every index I, we can have two options. Either we can take that particular coin or we can not take that particular coin. If we are not taking it, we are simply moving our index forward, and if we are taking it, we are keeping the index same because we can again choose to take this particular coin. But what the different thing we are doing in the take part, we are just subtracting coin of I from this amount, coin of I. In the end, what we'll be doing in the base case, we will be just checking whether our amount anywhere becomes 0. That means yes, we were able to make, or we were able to generate one possible combination. And since we need to have minimum number of coins, so what we can do in the final answer, we can just take minimum of this take comma not take. So yeah, this is about the problem. So we can just implement this same thing in the code, and DP solutions are generally like more understandable in terms of code rather than like explaining what I feel. So I would like to just directly show you the code and make you understand in more better way. So let us directly see the code now. So yeah, this is the code. So initially we are just taking a variable to keep track of the size of the coins array. Then we are just declaring a 2D DP. Now why 2D DP? So we need to take care of two states here. Now what are those two states? First of all, obviously the index I through which we are iterating. So for example, we have coins value as 1, 2, 5. So if your I is here, so we'll keep track on what index we are currently at and the amount value we have till now, because these are the two things which are changing. So we define states as which are of those things which are changing. So yeah, here I will be changing and the amount will be changing. So it will be a 2D DP. So that's why we are creating a 2D DP to keep track of the I and the current amount that we will have. And since like amount can't be from 0 based indexing, we are just doing like +1. And we are initializing it with -1. In the end, we are just calling this solve function or the helper function to give us the minimum amount of coins. And if we didn't get any combination, we are simply returning -1. Otherwise, we are returning the minimum amount of coins. Now, what we will be doing in this helper function or the solve function, let us see now. So initially these two are the base cases. So if our amount becomes 0, that means okay, we got one combination, so simply return 0 from there. Why 0? Because we are already adding 1 here itself, so that's why we are returning 0 here. Otherwise if you would be returning 1, we will be counting twice. If the amount is not 0 and we reach the end of the coins, that means we didn't find any combination. So since we need to return the minimum like amount of coins, so we can return int max or like simply 1e9 as large value as possible. So we are returning 1e9 from here. This is just the case of dp which we always do, whether the dp of I comma amount is not equal to -1. That means whether we have solved this I comma amount sub problem before, then return that particular answer for that sub problem. Otherwise we will have two scenarios. We can take that particular coin and we cannot take that particular coin. If we are not taking, simply just move our I pointer ahead. Now in what scenario we can take that particular coin, that is also important. We cannot take each and every coin. So let's say we have some coins array like this, 7, 8 and 9, and our target is, let's say, 11, and we have already taken this particular 7. So till now 11 minus 7 equal to 4. Now if we are currently at this index which has the value 8, so do you think can we take this value 8 in order to make this amount 0? No, we cannot take this, because if we do that, 4 minus 8, it will become negative. So there is no way we can take this element. We can only take this particular coin if our coin of I is less than or equal to the current amount that we have. So that is a check that we are making here. We can only take a particular coin if it is less than or equal to our current amount, and if it is, we are taking that coin. And if we are taking that coin, we are just incrementing 1 to our total amount of coin. So 1 plus and doing the same thing forward, just decrementing the current value from the amount, and we are at the same index. Why at the same index? Because we have the option to take this particular ith coin again, because we have the infinite supply. So this will keep on going, and in the end whatever results give us the minimum, we are taking either from take or not take. So whatever is the minimum, whatever is giving us the minimum amount of coin, we are taking that, and we are just returning that. So this was about the problem. It was a 0-1 knapsack kind of problem with infinite supply. So yeah, this was about the solution of this problem. So I hope you learned from this solution. Thank you for watching.